Hello everybody, welcome to our lesson. Today we will solve the problems on the topic the magnetic force on moving charges. Now this is the goal of the lesson. At the end of the lesson you will be able to use the equation of a force acting on moving charges and use the equations for the circular and helical motions of the charged particle. Now before we start solving problems, it will be useful to recall the last topic. So this is the Lorentz force and this is the force acting on a moving charge. And also this is the type of motion the charge performs when the velocity and the magnetic field lines are perpendicular. Here we have the equation for the radius of the circle and the period of the motion. And when the velocity is at an angle with the magnetic field lines, the charge will perform a helical motion. And this is the equation to find the radius of this helix and the pitch of the helix. Now, let's start solving from the first problem. So, what we have here, let's start with writing the givens. Okay, according to the magnetic field and the radius of the trajectories determine the type of charges. We know that the velocities are equal. These velocities are equal and this v. And we also can find the radius of the trajectory comparing the circles. So this is the 2 units, the radius of the first charge, and this is 1 unit. This is also radius of the second charge, and radius of the first charge is 2 units and the radius of the second charge is 1 unit. And we're asked A part to find the type of charge, whether it's positive or the negative. Not the magnitudes, just type of the charge. At B part, we're asked to find the ratio of the charges. Q1 over Q2 is equals to, it's unknown. And also, we have one more information here at the B part. At B part, we have information that masses are equal. So I can write mass 1 is equal to the mass 2. And it's equal to some mass m. So this is all the givens we have. And let's start solving from the A part. Okay, to find the type of the charge, we must use the right-hand rule. And if right-hand rule can be applied to the situation, it means we have positive charge. And if right-hand rule can't be applied to the charge, it means this is a negative charge. Remember, right-hand rule can be applied only to the positive charge. For the negative charge, it is the opposite. So let's start from the first charge. Align your fingers with the direction of the magnetic field and your thumb must show the direction of the velocity. And palm would show the force. So from right-hand rule, the force is here. At every part of the motion, force is to the center. It's to the center. It's before charge enters the magnetic field. The force is applied to the center. So it's obvious that this Q1 charge positive, because right hand rule can be applied. Let's look to the second charge. So we see the bendings, the charge bended to the upright. So it means the force must be directed to the center also. Let's use the right hand rule. The fingers must show the direction of the field, thumb direction of the velocity. And if I apply the right hand rule, the force must be opposite. So see, the second right hand rule can't be applied. So this is negative charge. We said in negative charge, force is always opposite. Now the B part. At B part, we're asked to find the ratio of the charges. So let's use the equation for the radius. It is mv, and we know this equal to the 2 units. And for the R2, it's m2 v2, and it's equal to the mv 1 unit. So from these two equations, Q1 is equals to 1 over 2 mv b, and Q2 is equals to just mv b. Let's find the ratio. Q1 over Q2 is equal to 1 over 2 mvb and mvb. So the mvb will cancel each other, and we have the final answer. It's 1 over 2, 0.5. So let's solve the second problem. What we have here? We know the velocity of the proton. It is 2 times 10 to the power of 5 meters per second. And we know the magnetic field uniform is 0.2 Tesla. And the direction is perpendicular, so the angle between the velocity and magnetic field is 90 degrees. A. We're asked to find the force acting on the proton. B. The radius of the curvature. Let's start solving from the A. And we also know the mass of the proton and the charge of the proton. So the angle between the velocity and the magnetic field is 90 degrees, so it means the motion will be circular. And it's enough to use the equation for the circular path. But first, we need to find the force acting on the charge. This is the general equation. From here, let's use the given informations and substitute into the equation. This is charge, velocity, it is 2, 10, 5 multiplied to magnetic field, it's 0.2, sine 90, it's 1. So force is here. If you calculate, you get the answer 0.64, 10 minus 14, and I can write in this form 6.4, 10 minus 15. The unit for force is newtons. The B part, the radius of the curvature. So the equation mv qb, and also we can put the givens into the equation. 1.6, 10 minus 27, 2, 10, 5 over the charge is 1.6, 10 minus 90 and multiply to the magnetic field. So 1.6 will be cancelled. The factors also cancelled. We have minus 8 here, 10 minus 8, and 0.2 will have 10. So this is 10 minus 7 and plus 5, 10 minus 2. So the radius is 10 minus 2, or 0.01 meters, 1 centimeter. So this is the answer for the second problem, and we are here to solve the third problem. In the third problem, what is given? Now we have the ratio of the charge and the mass. It is 5.7 10 to the power 8 coulomb per kilogram. It travels in a circular path, so the angle between velocity and magnetic field must be perpendicular, and magnitude for the magnetic field is 0.72 Tesla. We are asked to find the time to complete one revolution, so it's the period of the motion. Now let's use the known equation for the period. It is 2 pi m over qb, and we know everything here, but we don't know mass over q. We know q over m, so we can rewrite this as follows: 1 over q over m multiplied to p. Basically, I just divided both the numerator and the numerator by m. And now we can calculate, because we know everything. 2 pi I will use as 3. 1 over q over m, it is 5.7 10 to the power 8 multiplied to magnetic field strength 0.72. So the final answer, you can use a calculator. The final answer is 1.46 10 minus 8 seconds. So this is very fast motion. One revolution is made in this very tiny fraction of a second. Now the last problem, and it's about a helical motion. So let's write the givens first of all. What we know: a charged particle is projected into a uniform field. Magnetic field is equals to 40 Weber per meter square. But guys, actually Weber per meter square is the magnetic flux density, and this unit is equivalent with the Tesla, so nothing changes. 40 Weber, per meter square. It's the Tesla. What else we know? We know the angle between the velocity and the magnetic field is 53. And we know the velocity for the charged particle is 10 meters per second. And we know the weight of the particle. It's 1 gram. In SI, it will be 0.01 kilogram. And we know the charge is 0.1 coulomb. And we asked to find the radius and the pitch, the distance. So what do I ask to find? Radius and the pitch, D. So let's start from the A part. So I'm going to use the equation for the helix. Remember, we must use always perpendicular velocity to find the radius. And from here is mv sine alpha over qb. And let's put the givens into the equation. Mass 0.01 kilogram, velocity is 10, sine 53 over charge is 0.1, and B, magnetic field, it is 40. So from here we have 4, from here we have 0.01, and this is actually cosine 37, it's 0.8. So basically we have 0.01 multiplied to 0.8 over 4, and it is 0.02 meters, 2 millimeters. The radius of a path is 2 millimeters. And the pitch, what about the pitch? So actually the D, what we asked is the pitch. So I'm going to use the letter P after this. The pitch can be found multiplying the parallel velocity to the period, and it will be 2 pi m v cosine alpha over qb. V cosine, it's the parallel velocity, 2 pi m over qb, it's the period. Now let's put the numbers. 2p I'll take as a 3, 2 times 3, and mass it's 0.01 kilogram, 1 gram, 10, and cosine 53 over charge 0.1, and the magnetic field strength is 40. Again, here I have 4, this can be written as 0.01, this is 6, and cosine 53, it's sine 37, so this is actually 0.6. So what do we have? Also, we have 6 multiplied to 0.6 multiplied to 0.01 over 4, and if you calculate this, you get 0.09 meters, or P D is equals to 9 millimeters. So the final answer is this: the radius of the curvature is the 2 millimeters, and the pitch, the distance between the curves, is 9 millimeters. This is the end of the lesson. I hope you enjoy from us and learned If you like our video, please subscribe and share.